Okay, hi everyone. My name is David Burela. I'm the blockchain domain lead at Microsoft, and my talk today is on creating successful blockchain projects. Quick show of hands, did anyone actually get the reference of my original talk title? Yeah, so it was based on a dare. Someone was asking me, could I go and title my talk based on this little quote from Silicon Valley? The news reporter goes on and says, up next, the conversation every parent dreads, how to talk to your kids about the blockchains. So I put it as my talk title as a bit of tongue-in-cheek joke, but it's kind of serious because inside of Microsoft, it's kind of the conversation that every software engineer dreads, how to talk to customers about the blockchain. So based off the back of my talk from last year, anyone go to my talk last year? Hey, cool, this is all new for you. So last year I was talking about how blockchain is amazing, impactful, it's going to change the world, but I did it very, very high level, not too much architecture or how you could go about implementing this. So my talk today, based on how we can go and actually build these things. So for the last 2 years at Microsoft, I've been working with some of the largest companies around the world, helping them implement these blockchain projects. And I've been seeing again and again the same mistakes, the same problems, the same misunderstandings. So I wanted to go and show a couple of different architectures that we can that have been successful on some of these projects. So I'm going to be breaking today down into these 3 chunks. The first 20 minutes, I'm going to be talking about what is a blockchain and some supporting concepts inside of there, such as hashing. I'm going to spend 10 minutes on what I believe makes a good blockchain project and some anti-patterns, which I see all the bad ones doing. And then the last 30 minutes is me going over some of the real-world projects I've done with some of these large enterprises and run through how we architected it and why. Now, when you're doing a blockchain project, you can be doing it either in a consumer-to-consumer, business-to-consumer, or a business-to-business scenario. If you're doing anything with cryptocurrencies, that would be consumer-to-consumer, such as Bitcoin, Dogecoin, etc. I don't touch them. Everything I do is in the business-to-business space. So everything I'm focusing on today are on these B2B scenarios. If you're doing anything in C2C, you're going to have different things that you value as opposed to a B2B. Why would we want to do this? Now, if we think about as software developers when we're building applications for our 2 companies to speak together, it usually looks something like this. We're 2 separate companies. We've got our own siloed databases, and company A wants to buy widgets from company B, so they send through the purchase order, and that's all good until it's not. So we know that these databases always get out of sync. Month after month, they have to do reconciliations. Hey, the number of widgets are wrong. So who has to write off the wrong number of widgets? So there's a lot of manual time wasted because of this. So we may think, okay, let's not do it. Everyone's got their own data silo. Let's just have one source of truth, which is in one centralized place. And this is what we see with big players like, say, Walmart. Walmart just dictates to all of their smaller companies that work with them, hey, you all have to log into our centralized portal and you need to go into stuff into our portal and we're going to control all the data. But that doesn't sit too well with all the smaller companies because now they have to trust that Walmart are going to be tracking it all correctly, that they don't have a rogue IT admin that goes in and just changes the numbers in the database. Okay, another way we could do this, we could try to bring it out. So instead, we've now go and stand up a new standalone shared service that everyone goes and logs into. But then we're back into that same problem. Who's going to host this infrastructure? Because everyone has a vested interest to be the one that is controlling this. Walmart wants to, so do all the other companies. And this is where I find blockchain works really, really well, working in these multiple companies with a shared infrastructure. So blockchain, same marketing slide you would have seen again and again. The point of blockchain is that it's a secure, shared source of truth. The data is all stored in a ledger. Everyone in the network has a copy of it, and the ledger can only be updated via fancy network consensus. So a lot of big words to say. It's a big distributed, decentralized database. Everyone has copies of it, but the data can only be updated by some specific rules that everyone agrees to up front. What this allows us to do is if we can trust the blockchain instead of trusting instead of having to trust each other, then we can go and start re-architecting how we build these things. So instead of a traditional centralized system, such as that Walmart scenario, that everyone logs into that one portal, instead, if we have all of that data spread and shared across everyone inside of the blockchain in this decentralized network, we can change how everyone works in this system. And in my examples later, we'll build up how I would do this. And across all of these different companies that I've been working with, we're seeing that there's these same common use cases and scenarios happening again and again. Around asset transfer and provenance, cross-organizational workflow is the big one that I see, and multi-party auditing. So you can't get auditing just for free by if you do your transactions here on the blockchain, you're doing your auditing live as you're doing it. But before we dive into those ones, a few more concepts for us to look at. Now, everything that we do on the blockchain is being handled by old school public-private key cryptography. When I'm on, let's say, the Ethereum network, I create a public-private key pair, and I keep the private key private, as you normally would. The public key is used as my public address. So I can say, hey, everyone, I've got an Ethereum address. It's based on my public key, and anyone can send me money. Now, in this scenario, I'm user 1234, and I've got 50 Ethereum. If I want to send some money from my account to another account, I could just send a message saying, hey, please send 5 Ethereum from my account, 1234, to another account. The problem here is if I just send that message, everyone in the network would just ignore it because they don't know if I really sent that message because anyone could try to send that message. So how we secure it is because I'm the owner of account 1234 and I own the private key for it, I can now take my private key, sign that message, and now everyone on the network can verify that I was really, that message really came from me. I really do want to transfer 5 Ethereum from my account to someone else's account. And the network consensus will go update itself, and now we can see that 5 Ether has been moved across. So that's the first key concept to understand here. The next one is around hashing. A lot of things that we do with blockchain is based around us having to secure large amounts of data. This can be gigabytes and gigabytes of data. We can go create a hash and represent it in just a couple of kilobytes. The way that hashes work, so standard MD5 or SHA-3 hashing algorithms, we can take an input that will generate a hash as an output. That's the special unique property of this is if we just change a tiny piece of data, in this case we've changed a 5 to a 6, that would go and have a massive impact on the output. So this makes it very, very difficult for anyone to commit fraud by trying to change one piece of information because the hashes will massively change. We can verify it. Now, we can use these concepts of these public-private keys and the hashing of data to go and do some cool things on the blockchain. The first thing is around attestation. So attesting that something happened at a point in time that we can verify at a later point in time. One would be a home loan contract. So I've got a home loan with a bank. We could go and take that home loan, it's a PDF, create a hash of it, and put that hash up onto a blockchain. What that allows us to do is 2 years down the road, if I have a dispute with my bank, they'll probably win. But if we could negotiate, we would be able to have a look at the original contract, recreate the hash, and check if the hash is the same as what we put onto the blockchain 2 years ago. And we can see that the contract has not been modified. If the hash does not match, it means someone has modified it, and we could go off to court and we could appeal that. Another way is IoT data. So I see lots of people saying, oh, blockchains are too slow. We need millions of transactions per second to support these scenarios. Incorrect. If you're trying to put millions of transactions through a blockchain per second, you're probably doing it wrong. With IoT data, for example, if we've got 2 gigabytes of data from all this live IoT data streams that are coming in, we can take those 2 gigs of data, put it off-chain into just standard Azure blob storage. We can go and create a hash of that, and we can put that hash and secure that into the blockchain. So then 3 months, 6 months down the line, if we get audited and we need to prove that our IoT data has not been tampered with, we can just show the auditors here, if we rehash this 2 gigabytes of data, we get the same hash that we put up onto the blockchain 3 months ago. So using the blockchain is all about being smart and thinking about what you're actually trying to prove. Provenance is another one that we see around supply chains. So we see a lot of big things around people wanting to use provenance in supply chains to be able to prove things like fair trade coffee really came from these farms, or mobile phones are made from conflict-free minerals. So we can do this, again, just using those simple concepts of hashes. So we could go and create a unique ID for the CPU, motherboard, and RAM. We could go and take those 3 unique parts, and because those are being put into this one mobile phone, we could put those 3 hashes together, generate a new hash. So the great thing is these hashes, you can keep on adding with other ones, going down the lower. Yeah, you can keep going down and down and down. So what this allows us to do is at the end, we can go grab our mobile phone, we can check out what its unique ID was, check that up on the blockchain, we can see what the parts for that should have been, we can go verify them, yeah, they're all correct, and we should be able to keep going back, all the way back to the original minerals that were used to make up these components. So those are some of the base things. Now we can take this up a notch of complexity. And this is where we start getting into things around asset ownership. So we can do this for digital assets, and we're seeing that all these Generation 1 blockchains are starting to do this with money such as Bitcoin, Ethereum, Dogecoin, Dash, etc. That's an easy one. But we can start doing this for digital ownership of assets that are not just that. We can do this around ownership of movies and music. So I could go and purchase a movie or a music. On the blockchain, we can see that I own that. So if I go onto any other device, those devices can verify on the blockchain that I own this asset, and I can play that content. But by going and tokenizing these digital assets, now I can go and take that token and do unique things with it. So maybe I do want to lend that to a friend. I do want to sell that movie or piece of music off to a third party. It goes and changes around the economics of this. And this is what is really exciting about blockchain. Now we can move it on from just movies and music to some cool things like gaming. So for example, trading card games, Magic the Gathering, I used to play a lot in high school. You go buy them and you have to physically, you can prove that you own them because they're in your hand, so then you can use them to play. Same thing with the blockchain. If you can buy these booster packs and you can go and prove on the blockchain that you own these cards, then you'll be able to use those cards in online battles and prove that you own them. And same thing, I'll then be able to trade them with other people. Same thing with in-game items. So some of these things like Counter-Strike skins are being sold for multiple thousands of dollars, some of these skins. So being able to take them and put them into tokenized assets on a blockchain could go and unlock all of these aftermarket aspects of it. Now, there are ways to try to tie this concept of blockchain ownership to physical assets, such as cars, apartments, diamonds, paintings. But I'm seeing that a lot of companies are having difficulties of trying to tie that real-world physical item to its online blockchain identity. There's a difficult problem there of trying to connect them. So with apartments, for example, we could say that on the blockchain, I own this apartment, and we can do some cool things and extend it. So if I own this apartment, then I can go and take that apartment token, and I can go and put it up onto Airbnb. So then when I'm renting it out to people, that token's being rented out to people. I could then tie things like smart locks on my front door to that token. So whoever is currently got hold of that token has access through my front door. So it gets rented out to someone on Airbnb. When they go and rock up, they get access to the front door. Once the token's gone off them, back to me as the owner, when they try to go through the front door, they can't get it anymore. And this can happen automatically via smart contracts on the blockchain. Let's see. Diamonds have been done for tracking conflict-free diamonds. They actually go put the diamonds into the special machines, get all the dimensions of it, and create a unique cryptographic hash based off all those dimensions. So later, if those diamonds get stolen, if they turn up at another jeweler, they just check those same dimensions, regenerate the hash, check up onto the blockchain, actually this one has been reported as stolen. So that's a real one that's being done at the moment. And with paintings, as I said, there's a tough problem of trying to connect this Picasso painting with its blockchain identity. We see in the real world, people have certificates of authenticity that they keep with a painting, but what happens when they get disconnected? And there is no good solution for that yet. So at the moment, digital assets are really fun and awesome. Physical assets, difficult problem. Now, how all of this is done on the blockchain, I keep using this fancy word of smart contract. Smart contracts are actually very, very simple. People just conflate them to sound really complex. They look just like that. So that is a valid smart contract. They really are just like a piece of C# code or a JavaScript class. The contract is just like a class. By itself, it doesn't do anything. It's not until you go, just like a C# class, doesn't do anything until you say new person. And it'll go and instantiate that class into an object. At that point, it gets a place in RAM where it sits. And then you can go and interact with that object, and everything you do with that object is there and persistent inside of RAM. Same thing here with smart contracts inside of the blockchain. The smart contract sits there. The smart contract is just a file on your disk, doesn't do anything until you deploy it into the blockchain, which is just like instantiating it. At that point, it gets a unique address and is sitting there persistent on the blockchain. So I can call those functions which are sitting on there, and those functions can go and modify its variables, and these are like static variables. And that's how you go and do programmability in the blockchain. So in this case, I've got a unique Burela coin that I've created. We go deploy this out to the blockchain, and it's sitting at an address. And now people can go and call send coin, transfer, get balance, etc. And it's all going and interacting with that one instance of it. And as we're going and modifying it, those variables are being updated and persisted within the blockchain. And this is where the power of this comes from. Now, these smart contracts, the brilliant thing about this is you can start using them and making them interoperable. Now, just like in C#, you've got interfaces, and if you've got an interface, you can go and interact with any instantiated object which implements that interface because I've got the standard methods on it. Same thing here with Ethereum. So with Ethereum, there's Ethereum interfaces that you can use, and across the industry, there are some standards that are cropping up. Two really popular ones are ERC20 and ERC721. ERC20 tokens allow us to represent any token which we can just trade with anyone. So what this allows us to do is basically represent any form of money token, which is why we saw a few years back, we were seeing new blockchains emerging like a couple each month because people would be starting up a brand new blockchain with a brand new cryptocurrency. But now with this ERC20 token standard, now all of those can just be represented by a single smart contract, which is why you're now seeing token sales happening instead of people spinning up whole brand new blockchains, because this is a new standard. So blockchain Ethereum wallets now support ERC20. So with that one wallet, you've got your Ethereum money, but your 5 or 10 different tokens that you've got are all being tracked in here because of this standard interface. 721 is really fun and unique. Whereas ERC20 are for fungible tokens, just like Bitcoins are all the same, so you can trade them. ERC721 are for tokens that are not all the same. So in this case, we've got CryptoKitties, where each CryptoKitty is a unique one, just like Beanie Babies or something like that. And so each one is a unique one, so each one is a unique token. So whereas any two Bitcoin are the same and we can trade them without caring, any two CryptoKitties are not the same and we care about it, because if I've got the cool blue and white one, I don't want that mixed up with the boring brown one. The ownership of these tokens matter. Now, where this allows us to, again, we're just building up again and again and again. Now that we've got these standard interfaces and these standard ERC contracts, etc., we can now start building up some standard things. Now, what we can do, and this is where the main thing that I do with these enterprises, is we've got a scenario where we've got multiple companies all interacting with each other, and what was happening is if they were using web APIs or those type of things, they would have to integrate with each of their partners, and they would have to integrate with each of their partners. We're getting into N² scenarios. So what we found is if we put a blockchain in the middle, put in some of these standard Ethereum interfaces, all these companies could now just integrate with one integration point using these standard interfaces, and they could all start communicating with each other. And we drastically reduced the amount of complexity for these consortiums working together. So all these patterns that we were just talking about around provenance, logistics, orchestration, standard contracts, this can be applied across all these different industries. You can take a photo of that if you want, but basically all of the industries we've been working with so far globally have been across all of these. Now, that was me quickly trying to cover off why blockchain is good. So what I want to go into now is spend 10 minutes on what makes a good blockchain project. Let's start off with an anti-pattern. This is what I see happening again and again, and this is why I keep seeing people saying, I don't see the value in the blockchain. We usually have something like, let's say a Walmart. We've got multiple factories building things, supplying things to Walmart. So we've got the package there. And they'll all be logging into their portal. And they've got some back-end services, which goes into a database, and they've got some analytics and type of things. So they usually have the standard 3-tier architecture going on. And what I see all of them do is they say, let's take that blockchain, and remove it, and we're going to replace it with a blockchain. No. So what's happened here is they haven't changed anything. This is still a big centralized service. All they've done is replaced a really fast performance SQL server with the slowest, most expensive database that you can. So they've done nothing to enhance it. They've just massively bottlenecked themselves. This doesn't prove or help anything. Whereas if it was a big SQL database, we can cluster it, we can chuck through tens of thousands, billions of transactions per second. With blockchain nodes, we're going to be massively constrained. Now, when I ask them, why did you do this? They say, oh, it's brilliant, because now we can prove that all our data is correct and verified because it's all on a blockchain. And I'll ask them, you're verifying it to who? Because if they're just hosting it by themselves behind a firewall that no one can access, no one knows what is on the blockchain. So sure, they can prove that their blockchain data is there, but they can't prove that they didn't make it like that on purpose, or they didn't tamper with it and recreate the blockchain. We don't know how the blockchain got to that. If no one else is synchronizing that blockchain, if it's not decentralized out, it provides no value. And this is what I see again and again. You cannot just hide. If everyone can't access the blockchain to verify it, it is not valuable. Don't do it. So I'll start off with my red flags. If all the other parties go through party A's centralized infrastructure and can't see the blockchain. So that's what we just saw there. So these list of red flags I've given out to all of the sales guys at Microsoft. So when they're going and speaking with customers, they're going through this, and it's giving them a good cheat sheet to know where to start the conversation. Next one, there's no direct access to the blockchain to validate the underlying data. Everything's going through abstractions. So if everything is going through web services or web APIs in order to access a blockchain, then it's no good. So I see this happening a lot with people saying they want to do it for supply chains. Again, that fair trade coffee scenario. We want to say, we want people to be able to take this coffee and verify it. So how are you going to do that? Oh, it's great. They're going to load up our website and enter in the number, and they can verify it on our website. So, well, then if you're going through the website, how do they know it's not just a SQL database behind it? How are they verifying it? And this is the problem. If myself, I can't access the blockchain directly from my device to verify that this piece of data is there and correct, there doesn't need to be a blockchain. So this is a really, really difficult problem. How do we go about enabling access for these people to be able to verify it? Scenarios for a single company. I see scenarios where companies go, okay, we want to be tracking internally our to-do items or something like that. And so they don't need to verify any of this information to anyone outside of the company, so it's not helping anyone at all. Again, they're just replacing a well-known and well-tested SQL server with the slowest, most expensive database, distributed database that they can. Supporting systems are not yet implemented, such as supply chain logging, IoT sensor information. So I had one company who came up and said, we've got lots of cables and pipes and things like that, which go out onto jobs, and we're having lots of cables and pipes going missing, and we don't know if they're going missing because of theft or because of being used on jobs and not being tracked. We're not too sure. So we want to track this all on a blockchain so then we can verify where all these things are going. Okay, that's great. So how are you tracking it at the moment? Because we have to go and get that information, put it onto the blockchain. Oh, we're not. They're just taking it from the workshop and going. So then it's not going to solve anything. So people keep thinking blockchain's a silver bullet that will solve everything. But you can't solve it if you haven't got those underlying systems there in place. So when I went down into it, they realized that they could start tracking this with some IoT sensor information. We could start putting little RFID tags onto the cable drums. So when they're going out of the workshop, it automatically goes beep as it's going out, and we're tracking it going in and out. We can start tracking that for these houses. We know that 100, 200 meters of cable is usually used. So we can start doing some machine learning anomaly detection for if we start seeing 400 meters being used. So when we dove into it, we realized, hey, it's probably an IoT machine learning problem. Go and solve that first. Once you've got that data, then we can start tracking onto a blockchain. But you're probably going to solve your problem before you even get to the blockchain. Now, this one isn't something that is a blocker, but what I see is if not all of the consortium members who are part of this blockchain, if they're not all providing development resources, it's probably going to fail. So I see this happening a lot where one party, we've got an ecosystem of 4 or 5 companies, and one party says, okay, in private and secret, we're going to build up the blockchain solution, and then we're going to release it and get everyone else to join it. And no one ever does. Developers, we hate using other people's code. We hate using other developers' services even more. And so what I've seen happen again and again, when one party goes and builds up their blockchain solution, no other parties want to join it because they think party A just holds all of the things around it. So whenever I go and interact with customers and we build out these proof of concepts, I refuse to do it unless the company I'm working with, unless I bring in 2 or 3 of the partners. And so those initial pilots that we do, we've got developers from all 3 or 4 of those companies working together, building out that initial pilot, so then they've all got skin in the game, and they go forward from there. And since we started changing it around like that, we've seen a lot better uptake of these blockchain projects after we've left. Big no-no, which I'll dive into soon, is storing PII information on the blockchain, medical records, access logs, etc. I'll get into more later on. Now, the 5 key pillars that I see which are critical, first one being a consortium. So these are just kind of opposites of what were my red flags, but consortium, we've got multiple companies being part of the initial deployment. Again, don't build it yourself and try to get others on board afterwards. Get everyone to come to agreement and go and build this out together if you want it to succeed. Next one, it's a shared blockchain. So the blockchain infrastructure is hosted by all the parties. All the parties are validating the blocks. Infrastructure independence. Each party has their back-end systems directly connected to their own blockchain nodes and are not reliant on others. So I've seen some scenarios where they go, okay, we'll host a blockchain, but we'll still go through party A to access it. Now, again, all of these are not showstoppers, but it makes you at least think and pause about should we be doing this or not. Now, this one is a fun one to talk about with customers. The point of this, if you do this correctly, it should really be truly decentralized. So in theory, one of the founding members, the companies who are helping to start this, they could potentially drop out without the other parties being impacted. So a great litmus test for this is, hey, company A, if you were to go bankrupt tomorrow and you stopped, could everyone else in this blockchain network, could they continue without you? And they usually get scared and go, no, but we need to control the data. No, it's a blockchain. You don't control the data anymore. It's shared. You need to start thinking differently about how you're structuring these smart contracts, structuring this data. So this is the fun one. It scares them, but when we get over that initial fear, we end up with much better solutions. And shared API. Now, once we do have these smart contracts in there, we can, again, instead of having many point-to-point communications, we can just have that one integration point into the blockchain. We're using that as a shared API between all of the companies through these smart contracts. My closing slide, I've got these, so you see them again at the end. Now, let's start off with my big no-no, medical data on the blockchain. Now, I went into a medical insurance company, and they'd been doing this big proof of concept. And they brought me in at the end of them building it out for a couple of weeks and got me to review what they were doing. The idea of it was they wanted to make it really, really easy to make medical insurance claims. So there could be quick remittance, because one of the problems they were having is they wouldn't know their position until 2-3 months after the fact because all the paper stuff from doctors were taking a long time, etc. Okay, sounds great in theory. So I went in and they showed me and they said, yeah, cool, we're tracking everything on the blockchain so we can do this. So inside the blockchain, we're tracking the patient, the date, the patient's name, the doctor that they saw. I'm like, you can't do that, man. And they're like, that stuff's going to get leaked. This is really, really critical, private, sensitive information. This stuff's going to get leaked. And I told them, no, it's okay because the blockchain is going to be secured behind a firewall. No. So I tried to tell them, okay, so if you've ever been to a Troy Hunt talk, you know the data's going to get leaked. So it's all about trying to minimize your risk surface. So I told them, you already have enough problem with one SQL database being hidden behind multiple layers of firewalls and access control, and that data still gets leaked. How likely do you think it's going to happen once we've got this data being copied across multiple different companies? That's going to get leaked so quick. You can't put that information into there. So they accepted this and like, okay, that's fine. So we just anonymize the data. That stuff can be de-anonymized. So this happened just a little while ago. The Australian government took a bunch of medical data, they anonymised it and released it. And some people at the University of Melbourne discovered that they could go back and they actually figured out that they can re-identify it. Without decrypting the data, they could re-identify who the original patients were. With just a few mundane facts, they're able to identify 3 former PMs and an AFL footballer. So I told them, you can't just try to anonymise the data, you still go backwards. I went, okay, that's fine. We'll encrypt the data on chain. No, because you can still do things like frequency analysis. So you can see if this patient saw these doctors on the Monday, Tuesday, Wednesday, go back through another piece of data, you can cross-reference it. They're like, well, how do we do this then? That's a problem. That's what you need to solve, guys. Like, you're the ones building this up. So the moral of the story is I don't have an answer for this one. But the point of this was to take them through that journey of it's not as simple as just putting data up onto there. Think about what you're actually trying to do. You're just trying to prove that medical claims were done. So you might have to do this based on something else, such as insurance claim numbers or something like that. You can't do it based off private patient information. Now, as a counter to that, I went through the Microsoft marketing slides and I found this in our SharePoint. So this is a standard medical scenario that we've got for blockchain-enabled medical records. And there's some cool things in there that we could do in the future around taking a whole bunch of medical bioinformation that's coming off us, putting it into secure data stores, and then being able to optionally share it out with family members, medical practitioners, etc. Tied into prescriptions that you've got with a pharmacy. But again, we're going to have to resolve problems of securely encrypting that data off-chain, giving access, conditional access. So it's a difficult problem. Now, this was one of the very first blockchain projects that I worked on with an Australian company here, Webjet. So the challenge that Webjet had is that, here we go, a high volume of hotel bookings would experience discrepancies. Right back to my beginning slide where company A and B, they would have problems where the data wouldn't match and then they'd have to reconcile. Webjet were having this with all of their partners that they were booking with, hotels, wholesalers, etc. So how we did it was we've got Webjet, and Webjet would be communicating with multiple hotels and wholesale distributors. And the problem we also had was there were multiple other companies that were also communicating with them. So we had that problem again of multi-integration points. So all these hotels didn't want to integrate with the Webjet backend APIs, because why would they want to when they have to do it with 5 other companies? And then Webjet had the problem of trying to integrate with multiple different hotel chains and wholesalers. No one wanted to do it. And so there's a whole bunch of big legacy systems going on behind the scenes. So what Webjet thought is they were forward thinking, and they decided, what if we put a blockchain in the middle? So instead, again, we're going blockchain as that shared API. Everyone's communicating through the blockchain now. So Webjet were able to do this by deploying out a smart contract. And a smart contract, Webjet and the wholesaler would both put into that one, would deploy a smart contract per booking. And for that booking, Webjet would say what they think the booking is. The other partner would say what they think the booking is. The smart contract would verify that both parties think the same. If it does, everything's happy. If not, it'll raise a blockchain event. And then we had off-chain monitoring, which would go check this. So immediately would get an alert. It would be up on a dashboard. The Webjet core center would get that, flag it, and they'll resolve it immediately. Rather than 4 months down the line when the customer's trying to check into the hotel and the booking's not there. So Webjet were able to massively clean up the data quickly. And there's another company doing it. Now, the cool thing about this is, now other parties can just join on. So we've got other online booking websites that want to come and join this. You can. So Webjet have now released this as a product called ResChain, reservation chain, ResChain. So other companies can now come and hook into this, and we can easily onboard other hotels. So again, everyone's happier to, because it's now one integration point going through these standard smart contract interfaces. That was one scenario. I was a bit light on those ones because a lot of that is Webjet specific information. So I didn't want to dive into how they actually did it too much. Instead, I want to talk about one of the projects I love the most, which is one that we did here in Sydney with the Blacktown City Council. Now, the reason I love this is because of how we're able to go through with them step by step, and we came up with a solution which was really nicely decentralized and took all of the strengths of blockchain. So the scenario we've got here is we've got a big plot of land, and a property developer wants to come in and they want to build a number of properties and houses on it. Now, they can't just build the houses, they also need to build the supporting infrastructure. So they need to build roads, the water pipes, electricity lines, etc. Now, they'll also have to go and check that they're not going to be adversely affecting the environment, that they've got drainage plans in there, etc. So everything's not going to be washed away. What they'd have to do is go and get all of their supporting documentation, all the architectural plans, the survey plans, the environmental reports, this big, massive pile of papers, and fax it off, or send it off to them manually. Either way, they have to send a whole, sometimes it'll be on a USB stick, but there'd be a whole bunch of files that would be sent off to the Blacktown City Council. They would then take all of those documents and they would farm it off to multiple different government organisations. And those ones would have to go review them and then go and send back their approval for it. And same thing with the private sector. So the water utilities and the electricity utilities, they actually will go and take ownership of these water lines and water pipes and electricity lines. So they have to go and inspect them, make sure that the plans are okay. Maybe the water utility will come back and say, no, your drainage, your sewerage pipes are too small. You need to make them thicker. So they'll go back, the property developer would update the plans and send it through, but those plans wouldn't get through, redistributed to all of the other government departments. Everyone's approving old documents, etc. So when we went in and analysed this problem with the Blacktown City Council, we discovered that these applications, the approval times for this were taking a long time. Some of these were taking 18 months to 2 years. So these property developers were sitting on tens of millions of dollars worth of potential developments that they were blocked on for 2 years. We saw that this was a big orchestration problem across many organisations, which I've been trying to drum on again and again. This is a great solution for blockchain. It was very manual, paper-based. At any point in time, no one really knew the true status of the application, how many people had approved it, are we 40% of the way through? We don't know. Some of these updates may not be circulated, etc. And one unique one was discovery by the public. All of this was public information, and it was a discovery problem, public maybe not knowing that the development was happening, or they'd have to try to find these documents. So we wanted to solve all of these and make public discovery a lot more easy. Now, we did this pilot with a bunch of different companies. So again, how I said, I don't like doing these unless we have multiple partners in. So we actually had more than this, but these were the only logos I could find. So we had Business Aspect come in. So they donated a bunch of their developers for the week and business analysts. We had Sydney Water, Blacktown City Council, New South Wales Spatial Services, CRCSI, etc. And we spent a couple of days deep diving with whiteboards, envisioning out how could we go and build this out truly decentralized so that we can make this nice and extensible. So we started off and changed our thinking around to being blockchain first. So forget about legacy systems, blockchain first, how would we go about this? Now, we've got those pile of documents. So first off, let's start by creating a smart contract and deploying it out. And all the smart contract is keeping track of is the developer who is submitting this application, the date, and a few other bits of metadata. But we can't put the files on there because the files are really big. So blockchain is really, really expensive. You want to put the smallest amount of data that you can on there. So putting a 1 meg or 50 meg PDF file on there is impossible. It's never going to happen. So we have to think what to do with these files. Now, there's a brilliant piece of technology called IPFS, the Interplanetary File System. Awesome name. Now, I could do an entire talk just on IPFS because this is going to change the world just as much as blockchain is going to. So I may submit a talk next year at NDC just on this. But the quick takeaway for IPFS is take a big file, generate a unique hash for that. Again, I keep saying hashes again and again. So create a hash for this file. And with IPFS, it's a decentralized network where you look files up via their hash. So instead of doing it via a web server, bob.com/myfolder/thefile.pdf, the problem with that is if the server changes name or if you restructure the website for different folders, that URL is broken forever. But instead of accessing that PDF file via that long URL, if we access it via its unique hash, that means that we can go and retrieve it from anywhere. So if everyone in this room were using this application, as soon as one person's accessed that PDF file via its hash and it's down here in the room, because it's decentralized and peer-to-peer, if I'm going and accessing it, rather than going out through the internet, I can just access it via the local Wi-Fi. So we can start creating offline first applications. This is really, really powerful. Unfortunately, I don't have time to dive into it, but it's really, really cool. So what we do is next to the blockchain, we have IPFS to go and shove all of these files into. And these two things together allow us to do some really unique things. Now, the really great thing about this project was all of these documents which are submitted to the council, as soon as they're submitted to the council, they're available to the public. So we can make everything public first. We didn't have to worry about private information. Now, we've got the blockchain there, we've got the smart contract, we've got IPFS. So let's bring in the first actor. Blacktown City Council, they see that there's a new application there, so they'll review it and they'll say, okay, cool, let's farm it out to a couple of government organisations. And they can go and review it, and they can go and attach their approvals to it. And because it's a smart contract, they can attach their approval just by sending a signed transaction, and now the approval is attached to it immediately. Another cool thing is these files in IPFS, we're putting those hashes into the blockchain. So if we ever go and update those files, we just go and update the smart contract to say, hey, V1 is gone, we're now on V2, here's a new hash for it. So at any time, any of these government departments can go and get the latest version of the file just by re-looking up on the blockchain, what's the latest hash? There it is, okay, cool, and pull it back from IPFS. Now, let's change this diagram a little bit. So I've been just putting the blockchain in the middle and IPFS node in the middle, but really how it looks like if I strip it all back, really, each of these government departments are going to be hosting this infrastructure. Each of them are going to be running some blockchain nodes. Each of them are going to be hosting some IPFS nodes. So locally, they've got a local copy of the blockchain and local copies of those files as they're pulling them down from the decentralized network. Now, the great thing about this is, now that we've got this here, we can just start onboarding on other government departments as they become ready. So we don't have to go big bang, do everything at once. All the other older government departments that aren't ready to modernize can stay as they are. And as the IT departments get budget, they can start bringing it on. Because we're doing it all via these smart contracts, which are extensible, we can just start off with version 1 of the smart contract, with the signatures as just an array. But each of these are the ones that come on board. So these utilities, CAM, etc. One thing I skipped over when I went through the problems was Blacktown City Council has this problem, but all the other councils have the same problem. And none of them can come up with a big centralized service for this because same problem, who's going to host it? None of the councils don't really want to because none of them have budget to, who's going to develop it, etc. So we can keep on building it up. So now we can, when other councils are ready, other councils can come hook into the system. And because we've got the local, say, New South Wales Water and other electricity companies on here, as soon as other councils come on board, boom, they get access to all of the other companies which have been onboarded onto here. So we start off with that, and we got that built. So we only had, so we did a couple of days of envisioning, and then we did a hack fest with them. So we only had 4 days to go and build this out. So we built this out in 4 days, and we got it done in 3 days. So we had half a day, so we decided how could we go and extend this further? So because it's blockchain, it's much easier. If this had been a centralized service with one team dictating what the web API looks like to access it, then if we wanted to add in more features, we'd have to put in a feature request, wait for their team to build it up in order for us to have a new API that we can call. But because it's here on the blockchain, it's all there, open, ready for other people to take it and extend it. So what we did, we got spatial services were in the room. So spatial services, they go and look after all of the GIS information. So they keep track of, here's the source of truth, here's where all the property lines are, here's where all the roads, pipes, etc. And they've got a really hard problem because they keep 2 versions. They keep one for the world as it is right now with the roads and pipes as it is, and they keep a copy of everything that's been proposed. And the problem they had, especially with those lead times of 18 months to 2 years for these things to get approved, and everything being manual, paper-based, they had a hard problem trying to update the file, what it should be. But now it's in the blockchain, as soon as, oh, there you go, there's a map that they're trying to update. As soon as someone goes and updates one of these architectural survey plans with, hey, here's V2, here's V3, because it's on a blockchain, the blockchain raises an event. Hey, anyone who cares, this thing's been updated. Spatial Services cares, so they listen, they get that message. So on the blockchain, they hear, hey, there's a new version there. So from the local IPFS node, they just pull out, hey, IPFS node, please give me the latest survey plans of hash QQR. Pull it back, and then they can go regenerate it. So what was happening was their proposed layer was always way out of date, and now we're getting instant. As soon as someone submitted a new proposed thing, they were getting live updates. We were able to just add this on. It took us half a day to just go and extend that out. Now, what I love about this is how it was all public first information, that thing about discoverability by the public. So this is all the government departments hosting it, but the reason I architected it like this with IPFS nodes and Ethereum nodes was, let's make this public by default. So anyone in the community who cares about this, who wants to know what's happening and being built in the local community, they can go spin up their own archival node and they can start pulling down. So maybe they want to see what Adani is proposing to do, for example, or what the local supermarket is proposing to redoing roadways. Allows them to do it, but also allows us for a much easier start archiving data for long-term retrieval. So 20 years, 30 years down the line, when people are trying to figure out, hey, what are the old survey plans for that property development that happened 20, 30 years ago? it's in a filing cabinet somewhere. No, because it's all here done by cryptographic hashes on different archival nodes around the network. Now we can start pulling things down. And this is what gets me really excited, the long-term ways that government and public can start working together. Now, the last one I'm going to talk about was the architecture that we built. So we did a fun thing at Microsoft. So twice a year, they fly the people who, the software engineers who do similar stuff as myself, they fly all of us from around the globe to Seattle for a week to go and hack on some cool stuff. So what I decided to do was I built up a team. I got 12 people to join my team, and I wanted to see what would happen if we took Minecraft and combined it with blockchain. The idea behind here was to try to use it as a learning tool. So we can use it to try to show people concepts of how blockchain works, while also showing real-world architectures of how you could go and implement this in a real application. So I'll walk you through the scenario that we had. Now, a Minecraft server is a centralized thing. You've got one Minecraft server, and that Minecraft server has a world. And the world has cute things like pigs and diamonds. And we have players that are playing on that server. Now, the question I propose and want to see if we can build up is it possible for us to do land ownership within Minecraft, which is being stored on a blockchain? So we could subdivide that land out. And how will we track this on a blockchain? And how will we enforce rules? What we wanted to do is players could go claim a piece of land, and only the player who claimed and owned that piece of land, as it says on the blockchain, is able to build and modify blocks in that area. Now, we went through many different iterations of this because we've got a few problems here. Now, if we think about it, we've got a blockchain, we've got a game server, which is a centralized point, and then we've got multiple game clients because each player is playing on their own local laptop. And at which point do we shove in the blockchain? And there's no right answer to this. We could have gone and tried to create Minecraft client-side mods so the clients each interacting with a blockchain for them to do the transactions. But that seemed like a lot of overhead for players. They're already logging into that server, so they already trust the server is going to do the right thing on the game. So what we decided to do was put the logic into a Minecraft server-side mod. What a player would do, a player would, in their own Ethereum wallet, create a standard public-private key. So they've got an Ethereum account. So they'll go up to a piece of land they want. They would copy their public key, and inside of the Minecraft chat, they'll just paste in their public key, and then they'll go /claim land. And so we subdivided the world into like 20 by 20 blocks. So they go up to a plot of land, type /claim. And what that would do is that public key that we pasted, because it's only like 32 characters or so, it would send that public key to the server, just as a text message. The server knows the location for where the player currently is. So what we did, if you remember back when I said there are some standard ERC contracts, the ERC20, ERC721. Now, we couldn't use ERC20 for this because they're not fungible. Each of these plots of land are very, very different. I care which one I own. So we used a ERC721 contract to uniquely have a unique token for each of these plots of land. So inside of so we started off with the server being the owner of all of the 721 tokens for each of the plots of land. So when a player says claim, it would request to the server, okay, you are the owner right now, but could you please make me the owner? And that's what that message, play the animation again. Ooh. And so that's what the server's doing right there. It's telling the blockchain, the player with this public key is now the owner of this ERC20. Now, this works. And the server can verify whenever someone tries to build or mine this plot of land, because the server is the one at the end of the day that dictates if people are allowed to build or mine, it can just check on the blockchain. The player that's currently trying to build, are they really the owner? It can verify, yes, they are. So they can build. Someone is coming over trying to troll me. They try to build it. the server disallows it. And then, so we had that bit working, which was cool. But the point of this was to show that it's not just about land ownership, it's about we've now tokenized an in-game asset, and now we can extend this, and players now have control, and they can extend and decide what they want to do with it. So what we also built was a little website. So the players could go log into the website, and they're using that same Ethereum key to log into the website. On the website, they could see all the plots of land that they own, and they could go and click on one of them and trade it. So we would go and trade it to someone else's public key and say, this other public key, they are now the owner of this. The server would detect that, and the server now, when someone else tries to mine it, it'll detect who the new owner is. And so we had 4 days to build this out, and we got it working. So abstractly, that's what we're trying to do. This was my awesome architecture slide that I did to share internally to the team. So again, we've got Minecraft client. We've got the Minecraft server-side mod, which is where one piece we built. We built an Azure function that would sit in between the Minecraft server mod and Ethereum, because we didn't want to get the Minecraft server mod having to deal with Ethereum concepts. We've extracted that out into a Azure function, because the server-side mod would just ping a message to the function in order to send a message to Ethereum to do that. And again, we did that knowingly and willingly because we decided the Minecraft server was already that centralized point that people trusted, so it can be in charge of the contract, it's okay. But then off to the side, we've got Edge and MetaMask. Players could then go log into the website and they could go and interact with those ERC20 contracts. And again, they can, the website was just a convenience. Because it's all tied to their public-private, their Ethereum account, they could go and use a standard wallet. Because it's a standard ERC721, they could use a standard Ethereum wallet to send it to another player. The website was just a convenience. But we built this up as a reference architecture. Now, with all of that, the point of today was to try to show that blockchain is cool, it is awesome when it's done correctly. So if you take nothing else away from today, if you've got a centralized portal where you've just replaced the database with blockchain, please don't do that. Please just rethink how can we go and get everyone hosting these nodes, interacting with the nodes, and we're using the blockchain to communicate with each other rather than doing it via standard REST APIs. And think about ways how you can go and make everyone decentralizing this out. And remember, most importantly, never put anything on a blockchain that you don't want read. Because once you put it on there, you can't change it. There's no going back. So thank you very much, everyone. Please ask me questions afterwards.